Good morning, everyone. My name is Ferreira, and I'm part of the Faking It team. Our proposed solution for the task 1 of the BraTS 2023 challenge is entitled Enhanced Data Augmentation uses synthetic data for brain tumor segmentation. The proposed solution arises from the well-known problem of the lack of data for training AI models. AI requires a large amount of data to work properly, and in some scenarios, this data is not enough. In the medical field, obtaining data is very costly and time-consuming, and is also subject to some constraints such as data protection. One way to work around this problem is to use a data augmentation mechanism. For this method, the generation of synthetic data was used. The aim of our proposal is therefore to generate synthetic data and use it to train modern architectures such as UNet and the SWIN UNetR. The first method was to use registration to increase the number of cases available. This is done by using the ANT package to register each case with each other and create new samples that are a mix of these two cases. Using this strategy, 23,049 cases were created. The second method involves the use of generative adversarial networks. A conditional GAN was trained to insert tumors into healthy parts of the brain, reducing the discrepancy between healthy and non-healthy tissue, and to allow a fair comparison, 23,049 cases were also created. Here, we see two new cases created by registering the case 1 with cases 2 and 3. And as we can see, this method produced realistic and different data from the original data. The second method, using GANs, was more complex as it involved training a generator capable of inserting tumors into healthy tissue. The generator receives as input the healthy part of the brain, with noise at the location where we want the tumor, and the label, since we want to generate annotated data. Then both synthetic scans and label are used as input of the discriminator, as well as the real volume with the real tumor. The discriminator gives the probability of each case being real or fake, and this is used as feedback to the generators to stimulate it to generate more realistic cases. After training the generator, two strategies were used to generate new cases. The first strategy was to select random real labels to generate the synthetic scans, and the second strategy was to train another GAN to generate random synthetic labels and use these as input of the glioblastoma generator, the GliGAN, to generate the synthetic data. The dataset generated by this strategy is referred as G, and the one generated by the random label generator is referred as RG. Here, we see the difference between the tumor generated with the GAN and the baseline method. It can be seen that using a GAN allows for a more realistic generation. Three distinct networks were tested: the vanilla 3D full resolution NNUNet, the SWIN UNetR, and the improved NNUNet proposed by the winner of the 2021 BraTS Challenge. All networks were built on the NNUNet framework to take advantage of the framework pre-processing and post-processing. In the end, 9 models were trained and all the samples were tested. It's important to note that since this year a new metric is used that heavily penalizes the number of false positives and false negatives. False negatives are hard to avoid, but small false positives can be avoided by applying thresholds. Here, we see the best validation results of each ensemble with the best thresholds. It can be seen that the ensemble of all models gives the best results. However, if a less computationally intensive solution was required, using the model trained by the random label generator and the GliGAN would also be a very strong solution when compared with the other two assembles. However, as we aim for the most robust solution possible, the assemble of all models was presented with a threshold of 250 for the whole tumor volume, 150 for the tumor core, and 100 for the enhancing tumor. And to conclude my presentation, I would like to thank everyone who contributed in one way or another to make this solution possible, especially the organizers and sponsors of the competition, with a special thanks to Verena Jung who helped me with the submission, as well as my team, Victor Alves, Jan Egger, Naida, Janning, Philippe, and Jens Kleesiek for their great help, and thank you all for your attention. I hope that everyone is having a great time in Canada, and take care.